Next, linear system with random inputs. We'll see some basic definitions. System. A system represents a set of elements or functional blocks that are connected together to produce an output to an input. Whenever there is an input, it will give an output. For example, you take any machine, right? Otherwise, you take fan. So when you are giving the electric power into that, it will give, yeah, correct. Similarly, system is like that. For example, you take the function f of x is equal to 2. So you give any value to x. So the output is 2. Suppose you can take f of x is equal to x plus 1. If you give x is equal to 0, f of x is equal to 1. X is equal to 1, f of x is equal to 2. So that is called a system. Mathematically, a system is a functional relationship between the input x of t and the output or response y of t, which represented by L of x of t, which is equal to y of t. T lies between minus infinite to plus infinite, where L is called a system or transformation. You can take Laplace transform, Fourier transform, Z transform. All are a system, like a system, right? Whenever you are taking a Fourier transformation of a function, it will give something, right? Output. In Laplace transformation, it will give output. Z transformation, it will give output, whatever it is. So that is called system. It is denoted by L. If we assume x t comma s represents a sample function of a random process x t comma s, the system produces an output or response y t comma s, and a collection of such output functions form a random process. If input is a random process, the output also a random process, where s belongs to s sample space. Right now we are categorize the system in two. One is deterministics, another one is stochastics. First, deterministic system. If the system operates only on the variable t, treating s as a parameter, it is called a deterministic system. For example, a simple example, whoever operating the calculator, we know the calculator. So I'm entering in that 1 plus 2 will show 3. Suppose you are going to enter the same 1 plus 2, it will give 3. So whoever entering, it will give the same answer. There are so many examples like this. The system is deterministic system, right? It will give the same output for anybody, correct? Next is stochastic system. This if the system operates on both t and s, it is called stochastic. Stochastics, there are so many probability examples, right? If time varies, output also will vary, right? Each time you will get different output, correct? That is what. Linear system. If a system L satisfy the following linear condition, then it is called a linear system. Linear means straight line. Another word is straight line. Straight line means that is the degree of that polynomial or the equation is 1, right? X plus 2 equal to 0, x plus 3 equal to 1, x plus y equal to 1, right? In two variables, x plus y plus z equal to 4, linear, right? So this is so if L of a1 x t comma s plus a2 y t comma s, it is equal to a1 L of x t comma s plus a2 L of y t comma s, where a1 and a2 are constant. Otherwise, the system is called nonlinear, time invariant system. If the input and output characteristics of the system do not change with time, then the system is called the time invariant system. with respect to time, there will be a no change in the system. In a system y of t, which is equal to L x of t, if L of x t minus h is equal to y of t minus h. See, input in a system, time shift t, output y of t. X of t becomes y of t, time shift t, y of t plus tau. Now, time shift tau, x plus t plus tau, system y plus t plus tau, right? Time invariant, there is no change, right? Whatever it is. First, you give the system, then you change the time shift in the output. The same thing, you give the time shift in the input, then you will get the output, right? Example, consider the system y of t is equal to x 2t is equal to L of x of t. Applying time shift t plus tau to input. So L of x t plus tau, which is equal to x into 2t plus tau. X of 2 into t plus tau, replacing t by t plus tau, which is equal to x into 2t plus 2 tau. That is equation number 1. Applying time shift now, t plus tau to output, right? So y of t plus tau, which is equal to x of 2 into t plus tau, which is equal to x of 2t plus 2 tau. So from 1 and 2, y of t plus tau is equal to L of x of t plus tau. That is equal to x into x of 2t plus 2 tau, right? So we are considering system y of t is equal to x of 2t. So whenever you are giving time shift to y of t and your time shift to the input x of 2t, you will get the same answer. That is time invariant. Linear time invariant system, LTI. A time invariant system which satisfies the linear system condition, then it is called linear time invariant. So a system with both linear and time invariant, it is called linear time invariant. Impulse response of linear system. If in a linear time invariant system, the input of the system is an impulse function represented by direct delta function delta t, then the output is called impulse response of the linear system and is denoted by h of t. That is L of del t is equal to h of t. The convolution of two functions, we'll see f of t and g of t, is defined as f of t star g of t, right? Asterisk notation. G of t, which is equal to minus infinite to plus infinite, f of u, g of t minus u, du. So we are giving time shift to the second function, g, right? Is equal to same. You can give the time shift to first function, keep the second function same, right? Is equal to minus infinite to plus infinite, f of t minus u, g of u, du. Or f of t star g of t, which is equal to minus infinite to plus infinite. Instead of minus, you can add, right, u plus t, t plus u, f of t plus u, g of u, du is equal to minus infinite to plus infinite, f of u, g of t plus u, du. System in the form of convolution. Let the continuous random process x of t be a linear time invariant system whose impulse response is h of t. Then the output response y of t is also a random process. It can be expressed by the convolution integral y of t is equal to h of t star x of t. Convolution between h and x. That is y of t, which is equal to integral minus infinite to plus infinite. We are using the definition of convolution, h of u, x of t minus u du is equal to minus infinite to plus infinite, x of u, h of t minus u du, where h of u is nothing but L of del t, right? If x of t, which is equal to minus infinite to plus infinite, x of u del t minus u du, where del t minus u is a time function, right? We know delta function. Then the output is y of t which is equal to L of x of t which is equal to integral minus infinite to plus infinite x of u h of t minus u du, where h of u is nothing but L of del t minus u is the impulse response of the linear time invariant, right? X of t is integral x of u del t minus u, then output y of t is nothing but x of u h of t minus u. So that is the difference. Y of t is equal to h of t x of t. The same definition we are using here. See, if input x of t is x of u integral x of u del t minus u, then the output y of t is equal to L of x of t is nothing but integral x of u h t minus u. Del becomes h whenever you are taking linear transformation, time invariant transformation. See, input del t del t minus u x of t, right? System h of t whenever you are giving, so output h of t del t becomes ht, del t minus u become ht minus u system. That is linear invariant time invariant system. So x of t become y of t which is equal to x of t convolution h of t, right? Output signal. Thanks. We'll see you in the next video.